All right, let's talk about taking the radicals of negative numbers. All right, if someone asks us to find the square root of 16, what they're looking for, they're asking us to find the number that we could multiply by itself to get to be negative 16. There's a major issue here. I mean, the only contender I could think that would make any sense would be something like negative 4, because 4 times 4 is 16. But if we think about that, we try to multiply negative 4 times negative 4, it doesn't equal negative 16 because these negatives cancel when we multiply. And again, they cancel in pairs. So what we say is there's no real solution to answers like this. There's no number we can find that when we square it or multiply it by itself, we can get any negative number. Because when we square something, and if it was negative, the negatives would cancel. This isn't the case with this example down here with cube root of 8, or negative 8, because we can think of a number that we'd multiply by itself 3 times to get to negative 8. That number would be negative 2. And this is okay now because when we're doing the cube root, there's 3 multiplications here, and yeah, 2 of these negatives will cancel each other out, but we're still left with a negative number. And so the cube root of negative 8 is a negative 2. All right, so there's where we are in the world. We have no real answer to the square root of negative 16, but we do have answers to the cube root of negative 8. Well, as life would have it, we do have a reason to be able to take the square root of negative 16. And there's lots of applications in engineering and physics where we need to be able to do this. So mathematicians had to come up with something that would be able to be squared and result in a negative, or something that you could take the square root of a negative number. And what do we do as mathematicians? Well, we just say we invented something and they gave it a very interesting letter. They just said it's I. The definition of I is literally when you square it, you get a negative 1. That's as deep as it gets. So this is the new object. So if somebody said, hey, what's the square root of negative 1? What you would say, it's I. And the argument is, well, that's the definition of I. We've defined I to be the square root of negative 1, or I think more usefully, and it's the same sentence, is that I is the thing that when you square it, you'll get a negative 1. Then, with all things mathematics, we decided that wasn't complicated enough. If you can square I, then the question becomes, what happens when you take I and you cube it? Or what happens when you take I and raise it to the 4th power, or on and on and on and on? Well, the way to deal with this is you have to take these first two definitions of I into account. And so what it is if you're talking about I cubed, you would rewrite I cubed as I squared times I, or 1I. But we know that I squared is negative 1, so we can simplify this as negative 1 times I, which is another way of just writing negative I. So this is the first weird power I that comes up, but it is satisfied by our definitions above. And then I to the 4th I'm going to deal with in the same way. If we think of I to the 4th as an I squared times I squared, by definition I squared is negative 1, so this is just a fancy way of writing negative 1 times negative 1, which results in 1. Okay, so consolidated, what this is, we have I to the 1 power, well that's just I squared is negative 1, I to the 3rd is negative I. To me that's the weirdest one in the bunch, but we move forward. And I to the 4th equals 1. This right here forms what we call the cyclic nature of the powers of I. And again, to me, I'll just point out the most important parts of this are this statement, I squared is negative 1. That's literally just the definition of what I is. It's the thing that you can square to get a negative. We didn't have this before, but now we have it in our world. But also, as important is this statement right here of I to the fourth. And this is what's going to be the main issue or the main tool as we move forward with dealing with powers of I. All right, so here's the bigger picture. So we have this statement right here. Someone wants to be clever, and they say, hey, okay, so you have these smaller powers of I, but what about I to the 12th? Well, when I think about this, what I would do with this is I would break this up using I to the fourths, because these I to the fourths just end up being 1. So I to the 12th would be I to the fourth times I to the fourth times I to the fourth, right? Because our exponents add together. So this is an example of I to the 12th. But this is just 1 times 1 times 1, which would give us 1. Really, really fancy way of getting 1. In fact, if you can see how this generalizes, anytime that we get an exponent of I here that's a multiple of 4, it will always just end up being 1. Like I to the 16th is just 1, because that would be I to the 4th times I to the 4th times I to the 4th times I to the 4th. I to the 20th would just be 1. And we use that rationale to solve bigger and uglier powers of I. For instance, if someone gave us I to the 30th, what we would do is first split this into 2 parts. 1 is the largest multiple of 4 that's less than 30. In this case, that's 28. So I'm going to write that as I to the 28th times whatever is left over, I squared. All right, and the reasoning for this is, as the above explanation, I to the 28th is just 1. It's actually 7 sets of I to the 4th, but they're all just 1s, and so this I to the 28th part just becomes a 1. I squared, well, if we're any good at this, we all know that I squared is negative 1. And so what this simplifies down to is 1 times negative 1, which is just negative 1. So this is the simplified version of I to the 30th. Again, big picture, what we do is we take whatever power we have of I and find the biggest multiple of 4 less than it. That multiple, that I to whatever multiple of 4 is, in this case the 28 or 12 and above case, that by itself just becomes 1. We then are going to be left with the leftover part here that it will associate with one of these powers of I in this original 4. These are the only 4 unique products when we raise I, because the fact this I to the 4th is 1.